Good evening and welcome to WMFE's event, Bringing Mars to Earth. NASA's Perseverance rover has only been on Mars for a few months, but it is already beaming back incredible images, video, and sounds from the surface of the red planet. It's giving us the most dramatic and dynamic views we have ever seen as it searches for ancient signs of life on one of our closest planetary neighbors. We're going to dig into some of these incredible images and uncover the science behind the mission with WMFE's space reporter, Byrne. If you're a fan of the station, you know Brendan has been covering this beat with Are We There Yet?, which airs on 90.7 every Tuesday night at 6:30. It's also available wherever you listen to your podcasts, so you can take Brendan and your enthusiasm for space with you wherever you go. Joining us today on stage with Brendan is a very special panel of experts. Dr. Addie Dove is a planetary scientist and assistant professor in the Department of Physics at the University of Central Florida. Derek Demeter is an astronomer, photographer, fossil hunter, and planetarium director at Seminole State College. And finally, we have Joan Melendez Misner, who is a launch integration engineer and science communicator. Thank you all for agreeing to be on our panel tonight. And everyone, thank you for coming out and enjoy a wonderful program.
Thank you, Erica. We really do have such a fun night planned. Thank you all for coming out. And it's so exciting that the four of us can be up here. I think this is the first in-person event the four of us have done in a very long time. That's because we're all vaccinated. Thank you, science, for that, right? And we're so glad that you all could be here to celebrate so much cool stuff coming back from Perseverance. So we do have an exciting night planned tonight. Perseverance has captivated us all with stunning images and promises to unlock the ancient history of the planet Mars. And we're going to talk about the rover's thrilling arrival, the cutting-edge experiments, and its search for ancient life, and how it's paving the way for the future exploration of other planets. And we've got our great panelists here, Dr. Dove, Derek, and we have Joan. We're going to take some of your questions at the end of the program, so please, if you have any questions about what we're talking about, go ahead and tweet us, use the hashtag AskWMFE, and we will get to your questions. But first, we're going to meet Perseverance. So this is the Perseverance rover. Addie, I'm going to start with you. Tell us all about this robot that managed to land on Mars earlier this year.
Yeah, so everybody can meet Percy.
We're going to call it Percy, right? Because I can't spell
yeah.
Perseverance.
I say Perseverance.
Perseverance.
So. No. Perseverance, or Percy, as we like to give nicknames even to the rovers that we give names, is a super awesome, really, really advanced rover that is currently operating on Mars. And you can see here that it has this amazing suite of instruments. And I'm glad they're all listed here because I have trouble remembering all of their names because there's several of them and they're really awesome. But it's got this whole suite of instruments that's really helping us study the surface of Mars as it is now and helping us try to understand and unlock some of the secrets of its past. And it had some other payloads on board that aren't visible here that we'll talk about too.
For sure. Derek, I want to switch it over to you. How does this differ from the other rovers on Mars? We've probably heard of Spirit and Opportunity and Curiosity, but what makes Perseverance different?
Don't forget little Sojourner, too.
And Sojourner.
Yeah, so if you look at Perseverance just superficially, you'll see that it looks a lot like Curiosity, but it has some major upgrades to the cameras and the sensors and some of the digging tools and of course, what I'm excited about, the area where it's going to actually store some samples. So those are some of the big things that make and stand out this particular rover compared to the others.
And its wheels.
And its wheels, that's right. Yeah, it has some really nice wheels. That's
Joan, tell us about the wheels.
Yeah, the wheels, a little bit different than Curiosity, but the reason we were able to upgrade these wheels is because we learned from Curiosity. We saw that the Curiosity wheels would break down because of the terrain on Mars, so the NASA JPL engineers upgraded the wheels, made them a little bit more robust, made them bigger, and they also have a thicker aluminum so they can go longer and they can explore the area that it specifically landed in because it's tougher terrain than other other rovers.
Addie, let's talk about the science objectives of this rover. Why did we send this bugger to Mars in the first place?
I don't know if it appreciates being called that.
I'm sorry.
So why do we send any of our rovers to Mars? We have this sort of goal, NASA and other organizations have this goal of really understanding the history of Mars, but also the history of life on Mars and really looking for signs of life. So there's some mottos that are like follow the water, and we send different rovers and different landers with instruments on them that can look for things like water. They can look at the rocks and see how they've been processed throughout the history of Mars. And this rover has some really cool instruments that are going to be shooting lasers and taking samples and analyzing them with spectrometers to look at the composition and look for signs of organic materials and other things like that.
Why is that important to find out?
Because we have this question as humans, I think, right? Like, where did we come from, and are there more other living things out there than just on Earth? And so it's trying to understand a little bit about where we came from, about the history of life elsewhere, but also just understanding could life have existed there, and what changed over time, and how can we understand how that might tell us about life here on Earth.
Launching a mission to Mars is no easy feat. Percy launched last July on United Launch Alliance's Atlas V rocket. It was one of 3 missions to launch to the Red Planet last year. Joan, I want to bring you into the conversation because you are our resident expert as the engineer. This sounds like an extremely complicated task to send a mission to another planet. What goes into planning this?
I mean, it's not rocket science.
It definitely is rocket science.
I'm just saying. There's a lot of stuff that goes with launching rockets. There's, especially a mission like this, you have to plan years in advance. July was specifically chosen because it was at a point in time where Mars and Earth were closest to each other. And so therefore the journey to Mars was less than it would be at any other point in time. So when you're thinking about these missions, like I mentioned, it takes several years of planning. It takes several testing. As an integration engineer myself, I work for the Launch Services Program at NASA, and our mission is to launch these spacecraft to explore other planets, whether it's our own or in our universe. And so our main mission is to start from the very beginning of getting ULA on contract all the way up to the launch itself. And so it takes about anywhere between 4 to 6 years to launch this, and it takes several thousands of engineers, business analysts. Like, there's so many people that are involved that touch this specific mission. And the other element that was different was this mission launched during COVID, during the pandemic. So a lot of people were out there prior to the vaccine. So a lot of people were traveling to test a lot of the equipment that we were being used to launch the rocket. So we were going to the launch pad, we were going to different contractors to test, shock testing, environmental testing, to ensure that the Percy on the inside the fairing, inside the rocket, would survive the elements of the launch itself before it actually goes to Mars. And so, a lot of these people were, like I mentioned, they were traveling during COVID, and then, they had to social distance and do all this stuff. But yeah, there's a lot of testing involved. As an integration engineer, it's really neat because you get to be involved with, like I said, the business side of putting everything together. You get to work with all different types of engineers, whether it's electrical, mechanical. So you're kind of like the jack of all trades, and you need to know every single element of the mission because it's yours. And so it's just really neat to be able to be involved with the business side, the technical side, and then also be involved with the testing side. As I mentioned, one of the main things that we do is when we launch the rockets, we need to make sure that spacecraft, or Percy, ejects from the rocket itself. So we're very involved with the testing of that payload adapter. So once it gets to its location in space, the fairing opens and Percy ejects from the payload ejector, or the payload adapter itself. So it's really neat to be involved with the space hardware. And as a younger engineer, it's just really neat to be able to experience all of that.
We should mention it launched right from our backyard, right? This was from Cape Canaveral. This was, yeah. Derek, there are Mars launches only every few years, 2 years. Explain to us why that happens. And when we launch something to Mars, we don't look for Mars in the sky and then shoot at it, right? We have to figure out where Mars is going to be and aim in that direction, right? Tell me the complicated math that happens, but simplify it for me, please.
Well, Joan talked a little bit about this earlier, that essentially we have every 2 years or so to really launch something to Mars because the distance between Mars and the Earth is at its minimum. So, we're talking, this past year we had what's called the Mars opposition, essentially where Earth and Mars are essentially roughly about, could vary between 50 to 70 million miles or so. It does vary from time to time because our orbits aren't completely circular and so on. And what we want to do is we actually want to launch this thing a few months prior to that event because what we'll do is we'll launch it and it'll be able to kind of fall into that trajectory that will make its way to Mars. So usually when we want to launch something, we want to wait for that window of opportunity. In fact, actually when it launched, I think it only had a few more days left in the launch window. Otherwise, we'd have to wait a whole another couple of years. So that was definitely, finger biting. Oh my goodness, is this going to happen? But thankfully it did, and it was a spectacular launch.
I was going to say, especially with Florida weather.
Yes,
you
July.
You can test and you can analyze everything, but then Florida weather just destroys everything because it rains that day or the terrain is different.
And that has happened for Mars missions, right? There have been missions that have been delayed because of technical issues, and they've had to wait 2 more years before they launch, right?
Yes,
right.
Lots of times, yeah. And it's
Yeah, the Phoenix mission,
Yeah.
the last time, it was delayed because of an instrument issue, and it had to wait a year and a half, 2 years to launch. So,
Well, there were a lot of missions that took advantage of this window, and Perseverance wasn't the first rover to make it to Mars. The United Arab Emirates Hope Orbiter reached Mars back on February 9th. It was the first one to reach there. It's the first interplanetary mission for the Young Space Agency and sent back this stunning image. This is the first image from its onboard camera. Addie, what are we looking at here?
it's Mars.
Are you guys following along? Did you guess that was Mars?
Did you think
Write
that was
that down.
coming? So this is an amazing picture. UAE has this small or new space program, and they worked with a lot of folks here in the U.S. to build the instruments. But one of the instruments is a camera, and this orbiter. So it's an orbiter. It's staying in orbit around Mars, and it's a little bit further out, so it can actually see the whole disk of Mars for a lot of its mission. A lot of our other orbiters are close in, so they can zoom in on the surface and see close-up views. But this one's giving us these really awesome full disk images. And you can see here a chain of volcanoes, and then up in the sort of top right, there's actually Valles Marineris, is the big canyon system on Mars, and it's just being obscured a little bit by some clouds. And you can see the sort of haze on the edges of the picture is Mars' atmosphere.
I didn't think Mars had an atmosphere.
It barely does,
Okay.
but it's enough to show up in pictures like this. Yeah, it's got a little teeny tiny atmosphere.
So this might be a dumb question, but that's what I'm paid to do, is ask dumb questions. What's the difference between the Hope orbiter and something like a rover on Mars?
One is orbiting, so it's going around the planet. It's staying in space, staying around the planet. So like all of our satellites that are in orbit around Earth, right? Versus a rover goes down to the surface. And there's differences between landers and rovers. So a lander is usually just one that lands and is stationary, and then the rover can usually drive around. And so Percy was just a rover system. We have several other spacecraft, though, that are in orbit. NASA has several other spacecraft in orbit around Mars right now that relay data back from Perseverance.
Derek, what can we learn from a mission like the Hope orbiter? What can scientists expect to get back?
So what Addie mentioned about these other missions, so one of the things it's going to be looking at is, speaking of the atmosphere, very little atmosphere, and we actually think that a long time ago, Mars was much more Earth-like. It had a lot of oxygen in the atmosphere. That's what, essentially the red planet, it's called the red planet because of the oxidation, the rust. Basically, Mars is a giant rusty nail because of that oxygen in a lot of the soil. And another thing we've discovered is, I'm sure some of you have heard of auroras, like Aurora Borealis and Aurora Australis, the northern and southern lights. Those are caused by solar radiation hitting the Earth's magnetic field. Well, we actually, with a mission called MAVEN, which is another orbiter that's actually studying the atmosphere of Mars, has found out that the sun's radiation is actually creating what's called proton auroras. They're actually stripping away the atmosphere of Mars. And Hope is hoping, there we go. Hope is hoping to look for more signs of why Mars is losing its atmosphere, how that affected the early Mars, and that will actually join up with conditions like and prove that, well, Mars was a wetter planet. It could possibly have the conditions for life. So in reality, Hope is going to help us figure out that in conjunction to Perseverance being on the surface.
Addie, there was Hope, there's Perseverance, and the Chinese Space Agency just landed its lander this week. Tell us a bit about that mission.
Yeah, so the Chinese mission has both an orbiter and a lander/rover system. So this was a really ambitious mission. It's actually China's first mission to Mars, and it was successfully went into orbit a little bit later than the other two. I forget what day it was. It was also in like February, though.
February, around that time. Yeah.
And then just about a week ago, the lander landed on the surface. It's in Utopia Planitia, which you can't see on this picture, actually, sort of on the other side of the planet. But that's where we actually landed the Viking 2 lander back in the 1970s. And it's also where the Utopia Planitia shipyards are, if you're a Star Trek fan.
I think we might have a few Star Trek fans out there. Huh?
And so it has a little lander. It landed about a week ago, and then the rover drove off onto the surface a few days ago, and we just got those pictures back yesterday or today. And that rover is much, much smaller than Perseverance, but it's also studying a little bit about the surface of Mars. We think that there's probably subsurface ice in that area, so it's a really interesting potential landing site for future missions as well.
These are all cool missions, but we're here to talk about Percy.
Okay,
right?
Let's bring it back.
So NASA's Perseverance rover made its landing on February 18th. Mission planners called it the 7 minutes of terror. Joan, that sounds absolutely frightening. Why do we call it that?
It is frightening. No, so the 7 minutes of terror is what they call the entry descent phase, and that's the point where the Percy enters the Martian atmosphere, and it takes about 7 minutes to land on the red planet. And at that point, it's called the 7 minutes of terror because it's doing it all autonomously. It's doing it all by itself. The delay in communication between Mars and Earth is about 12 minutes. So by the time it lands, the NASA JPL engineers would not have known that it landed for several minutes, and so therefore they've worked their entire lives, most of them working on on Perseverance, and they can't really tell whether it's landed. And this is the first leg of the mission. So if it doesn't land and something happens, then that's the end of Perseverance, and that's it's extremely terrifying. And so therefore they want to make sure that the mission successfully goes up to plan, and so therefore this is the very first leg of the mission is to land on the red planet.
So walk us through what actually happens, because we're looking at this image here. It looks kind of crazy, but Perseverance, this is an illustration.
That's a sky crane.
And Perseverance is attached to a rocket-powered crane, which lowers it onto the surface of Mars, right? Is that not insane?
Yeah, so it's pretty neat because, when it's entering the Martian atmosphere, it's going, extremely fast. And so at one point, you have to slow it down for it to not crash onto the red planet. And so therefore, they use the sky crane. Once it goes into the Martian atmosphere, there's several points in it. I think at one point, the heat shield breaks off in order for Percy to survive, and therefore the sky crane, which has about, I think it was like 7 or 8 rocket engine, or around it,
just
like
a few.
thrusters. Yeah,
just a few.
Just a few. For it to essentially slow down. And the neat thing about this is that its intention is to just land Percy on the red planet and then go off and crash somewhere else, because the life of that specific sky crane is done. So once it goes to a specific portion of the 7 minutes of heaven, the sky crane comes out of the descent element, and therefore it takes it to where Percy is going to be landing, which is the Yezero Yezero Crater. Yeah. And so I just learned how to say it correctly.
I keep saying Yezero.
I just keep saying Yezero. I'm like, I don't know, Yezero Crater. And so therefore, the cool thing about this, though, is we also tested really new technology. I believe it's called relative navigation. And so once Percy gets to a certain point, the parachute deploys. That parachute is taking pictures, real-time images, and telling Percy specifically where it's going to be landing, which is really neat. And again, all of this is happening autonomously. The NASA JPL engineers cannot control it at this point, and that's again part of that 7 minutes of terror. And so therefore, it's telling Percy where it's supposed to land, and then once it figures out where it's going to be landing, the sky crane lets it loose, and cables bring it down. And once Percy, the wheels can sense that it's on the Martian surface, therefore the cables get cut, and then the sky crane goes off to land somewhere else and essentially crash.
It sounds absolutely wild that it's able to do this, but what's even wilder is we have video of it. So
Yes.
let's go ahead and watch this video of Perseverance actually landing on the surface of Mars. And Joan, I hope you will walk us through this as we're watching it.
We are starting the straighten up and fly right maneuver, where the spacecraft will jettison the entry balance masses in preparation for parachute deploy and to roll over to give the radar a better look at the ground.
This is the JPL
This is
mission
control.
operations.
Yeah.
Indicate shoot
So
deploy.
a cool little thing, I don't know, the Easter
The
egg on this
navigation has
parachute
confirmed
itself.
that
So
the
it's a
parachute has
binary
deployed,
code,
and we are
and a
seeing
lot of
significant
people out there,
deceleration
not myself, figured out
in
what it
the velocity.
says.
Our current
So
velocity
NASA
is
JPL love to
430
put
meters
little
per
Easter
second
eggs
at
in
an altitude of about 12
their
kilometers from the
spacecraft, and in the
surface of Mars.
specific parachute, it's the binary code was Dare
Heat
Mighty
shield
Things,
set.
which is the
Perseverance is now
NASA
slowed
JPL
to
logo.
subsonic
And that's the
speeds,
heat
and
shield
the
falling
has
away
been
there. And now we're
separated.
actually looking
This
at
allows
video
both the
of
radar and the cameras to
Percy
get their
and this
first
landing
look at the
apparatus
surface.
Correct.
looking at the surface of Mars and trying to find where it's going to land,
Right,
right?
and that's where that technology that I talked about earlier, it's taking images of where specifically it's going to be landing and telling Percy and kind of directing it where it's supposed to go, all autonomously. Again, NASA JPL engineers are not involved whatsoever. If something goes wrong, they will not know that something is wrong until 12 minutes after.
Yeah, this terrain relative navigation, they tested it
Yeah,
a bunch
filter
here on
confirmed.
Earth with some
Velocity
different
solution,
rockets, like in the
3.3
desert,
meters per second.
and they tested it on different
Altitude,
vehicles, and then they were
7.4
able
Now
to
has radar lock
implement
on
it
the
on
ground.
this.
Current
If you ever go to
velocity
Death
is about 100
Valley,
meters per
that
second,
is Mars on Earth.
6.6 kilometers
It's pretty
of the surface
wild.
of Mars.
And we're looking at images that this vehicle is seeing as it's trying to
Perseverance is
find where it's going
continuing
to
descend on
land, right? I mean,
Panoramic.
I don't think I can just put into perspective how crazy this is. This is so cool.
And also, like, where it's supposed to land. So, like, throughout the other rovers that have landed on Mars, the cone of where it's supposed to land, each single time it's gone a little bit tighter. And so it's just really neat that the technology that we've used from previous
We have
rovers to
confirmation that the
land
land
on
division system has
in this
produced a
specific
valid
terrain,
solution
the
as part
Yezero
of
Crater.
terrain
I'm going to say it
navigation.
right one of these days.
Priming.
No, you're doing good.
PPAs
And the thing that's crazy about it is,
We have
it's
timing of the
constantly
landing
computing.
engine.
All these little green squares and stuff are figuring out yes, no, don't go there. It's mind-boggling the amount of computational analysis that's happening. And you were talking about earlier what some of the other missions have done. Curiosity had a very similar, but it wasn't as advanced. But the missions prior to that, they were smaller. They actually used balloons that bounced off the surface. So this, again, just some of these crazy ways that we've been able to get spacecraft out.
And I think in a few minutes we're actually going to see that sky crane in action because at this moment it's
Yes.
locked into where it's going to land.
Right.
It's picked where it's going. The sky crane is kind of using those thrusters to get it where it needs to go. And in just a few seconds, we're actually going to see the images of that sky crane. You can see that dust being kicked off. And here we go. This is my favorite part of this. There's the sky crane. The top part there is the sky crane. The bottom part is Percy being lowered to the surface.
20 meters off the surface.
How
So it's about
incredible is that?
66 feet from the surface.
66 feet? That's 6 stories. This thing is coming down. That's crazy.
Yeah. Well, you don't want it to get, because those thrusters, you don't
Tango
want all of
Delta.
that Martian
Touchdown confirmed.
dust and stuff kicking up to Percy just because it's extremely
on the
advanced.
surface of Mars. Ready
So this
to
right
begin
here is my
digging the
favorite part.
sand.
This is the human element of it. It's as if we're all part of that mission control. Because again, they see this video, it's delayed. So they see this video after the fact. And so it's just really neat.
And they say Tango Delta, touchdown, right? That's so impressive that it landed safely. Let's talk about a bit about Percy's new home, which is Yezero Crater, right, Derek?
Yezero.
Is that how you say it? Yezero Crater? Derek, what do we know about Yezero Crater? Why is Perseverance hanging out in this particular spot on Mars?
Well, the primary mission of Perseverance is to look for signs of ancient life. And Yezero Crater actually was thought to be an ancient lake. So if you look up towards the top left, you can see almost kind of like a snaky type windiness. And we think that is, or we've been able to do analysis on it, that there is an ancient river that would have came down and washed a bunch of deposits down into the lake that you see here. So Yezero Crater is this home to this ancient lake that has been deposited minerals and all these things that are necessary for potential development of life. So
It's as big as Lake Tahoe, right?
yeah, it's about as big as Lake Tahoe. So
I
you've
have,
been to
I have
Lake
to, I
Tahoe?
have to stop you right there. So there was water on Mars, right?
Yes.
That's why they're so interested in this part.
Yeah, and of course, curiosity helped us find out that there was, in fact, water present on Mars because of clay deposits, beach erosion, things like that. This, however, has the potential of being a place where it could have been teeming with life.
Yeah, there's always a really hard line to find between sites that are really interesting on places you want to go. So if we're going to the moon, or if we're going to Mars, there's always sites that like the scientists want to study the most interesting sites, but it turns out those are usually like the dangerous ones
the
to
most
land
dangerous.
in.
Oh, yeah.
Because they're going to be really rough terrain or like at the edge of a crater. So Yezero is a really interesting trade space they figured out to say, okay, we're going to land in this place. It's got a pretty nice flat region. And they landed, you can see up in that top left, because it's really near this delta region where a lot of the action might have happened and a lot of those really interesting deposits that we've been able to tell from orbital images. There's really interesting deposits there that we can study.
So why do we think there is going to be signs of life in this river delta? Why is this where scientists want to explore, despite how dangerous it might be to get there?
Yeah, so they landed sort of down at the bottom of the delta, and they're going to be slowly driving up into it. And there's different types of rocks there. So there's like rocks that have different types of signs of different water processing. So we already mentioned it probably was filled at some point and was a lake. But if you have flowing water, it will modify rocks. It will create deposits of rocks. And we see a lot of that sort of water metamorphosis happening in Florida. And it modifies the things that are left there. And you're left with deposits. And if there was life, additionally, you can get deposits of things that are only made by biology, for instance. We're not probably going to find fossils, unfortunately. Sorry.
No
but
giant mammoth
Never
bones.
say never. Never say never.
Just send Derek up there.
Yeah, exactly. He'd find them. But we will find signs of like things that have been processed by life organisms. And it's hard to sort of see that from the surface, so we have different instruments that can drill down a little bit, scoop up the regolith and rocks and process it a little bit. And as we mentioned, it's going to cache some rocks and dirt that are going to be put into a little pod and saved for a future mission to come and pick up those rocks and bring them back and do a Mars sample return.
Mars sample return mission, exactly.
Yeah.
So when you say we're going to find evidence of other things there, what are we talking about? We're talking little fossils, little
No
ancient
fossils.
poo? What are we seeing?
One of the things we can kind of compare it to is here on Earth we have biosignature rocks that are developed from organics like stromatolites here on Earth. So, for example, stromatolites are built off of what's called cyanobacteria, which have photosynthesized, and they're essentially their byproducts are this material, this encapsulated rock, if you will. And that's the kind of stuff we want to look for. Basically, life that once was there, that was building material. Limestone, for example. Limestone, which is all found all throughout. If you go to some of the springs here in Orlando, like Wekiwa or Kelly Park, all that lime rock was either deposits of ancient sea life or built from ancient sea life, like corals and seashells and things like that. So that's the kind of stuff we're seeing, basically material that has been washed out. We call that alluvial deposits, basically washed out from water that have been deposited in these areas.
Mm-hmm. Joan, the scientists want to go to a place like this and explore because obviously there's really cool things for them to find, but it could be dangerous. As an engineer, when you think about the place that Percy is, how do you engineer a vehicle to sustain itself there and to make sure that it can explore it safely? How much of the environment goes into the design of the vehicle?
A lot. Yeah, so I mean, I can't really talk as a NASA JPL engineer because they work on this for years, but the past missions, they learned from it, like we talked about the wheels. We saw that Curiosity's wheels were broken down and they were breaking down. And so therefore, you think about all of these different designs you learned from previous missions to engineer or to build upon to, essentially have Percy last a little bit longer than the previous ones. Sorry. And so, thinking about that, that's a really cool thing about being an engineer is just being able to tinker with all that stuff. You have a vision, and therefore you ensure that before you send anything up there, you test to, test forever so you can ensure that all of this survives when you're out there. And so therefore, a lot of the NASA JPL engineers, again, they've worked on this for several years. And so therefore, it takes a lot of effort for them to go out there and do this. And the cool thing is they have some kind of environment out in California in the desert that they can test a lot of these things. They can test the wheels. They can test, make Percy a little bit more robust. This one, again, is a little bit bigger because the instruments are different than they were for a Curiosity. But, it just takes a lot of effort and a lot of just design work to go through it.
Mm-hmm. Good, Addie.
Yeah, I was going to say, and they have to do everything from launch to landing, right? So you have to be able to survive launch loads, which is something you are always nervous about, I'm sure.
Loads, shock,
it's not
all
easy,
of that.
right? Like blasting off this planet is not an easy feat.
Yeah.
Right?
No, and that's the cool thing about working on the launch side of things is you, as an integration engineer, you get to work with flight dynamics, you get to work with loads, you get to work with shock, because in order for it even to get to Mars, you have to survive the launch environments of getting it off the planet, and so therefore, all of that is being tested. It's analyzed, through computer modeling, and then right before launching the actual rocket, it's going through like a launch campaign, and therefore you actually test all of these different environments to ensure that Percy will survive, because it's extremely expensive equipment on there. So we want to make sure that it gets to Mars.
Yeah, there was a story the other day about James Webb Space Telescope, JWST, and that's a telescope that's going into space. It could be a really flimsy thing and it would be fine in space, but it has to survive launch loads to get up there, and then making the mirrors and all of the hardware to survive that is intense.
Yes, it is.
Well, Percy survived launch. It survived landing, as we saw. And as you mentioned, it is in this ancient river delta. And it sent one of the first panoramic images sent back is this one right here. So this is an image from the surface of Mars. Addie, I know, yeah, it's worthy of an applause. Let's give that little bugger an applause for sending this back. We saw some engineering images that came back. This is one of the first panoramic, and this is just a very small slice of a very wide image that came back. I couldn't fit it all in the PowerPoint. That's why it's cropped. We can put it. But
right.
That's
we
right.
can do it on the planetarium.
Well,
There we
go to the
go.
planetarium
Yeah.
and see it. You're like on Mars.
Around you.
Addie, as a planetary scientist, when you see a first image like this, what goes through your mind?
There's a lot of rocks and dust there. So a little background is I study dust on other planets. And so one of my actual first impressions is like, oh yeah, that's a lot of dust. But more technically, I'm always stunned by these images and from Mars and from other surfaces when we land, just how magnificent the landscapes are and just how real they are, right? So just like this could be a picture from the desert that they took prior to launch. They didn't. This isn't. This is from Mars. But it's...
Promise? You promised, Eric?
Yeah, we promise.
It is from Mars. Yes. You have the stamp and
You can,
seal
yeah, it's got the
approval
metadata
from me.
on there. If you look at the image, it's got some metadata that says Mars. But so, right, so this is it's an alien landscape, but it's so Earth-like. It's so, it's just like here at home, and I don't know. I'm always amazed. And then you look into the details of like, okay, how big are those rocks? What kind of other features do you have around? You see these hills nearby because we're in this crater region. And a lot of times on the Mars surface, you can see stuff really cool in the near ground, and you can actually see how the surface has been modified by the landing. So you saw when it was landing, there were the streaks and the plumes as the engines were firing, blowing all that dust away. So you actually modified your surface nearby. And then the other thing is, as you're looking at this picture, you're like, okay, that's not going to be super fun to drive over. Where are we going to drive?
The engineer is
Also,
sweating bullets
camera.
over there.
Yeah, definitely. So, I mean, the camera. I mean,
Yeah.
this one has about 19 cameras. And
Yeah,
we have this image here that we took on another planet, and it's better than if you go to a bank camera and let's say you're there, you're all blurry, but we can take an HD picture of a terrain on Mars. That's pretty neat.
Yeah.
And here's another image from the surface. We're taking a closer look at one of these ancient sediment deposits. Like this to me looks like something on Earth, does it not? Like this is wild to
That's
look
my backyard.
That formation back there is called Kodiak. So I like the name of it. It sounds cool. Yeah, I mean, this looks like something. If you were driving in the Mojave Desert in near Death Valley, you literally you wouldn't really tell. You would think you're on Mars, you know. But you can actually see the crater rim in the background to just show you the depth of this image. I think that's absolutely incredible. But you can see that you have basalt rock, which again, this used to be also an ancient impact crater site. So you have a lot of impact ejecta regolith there, but you also what it looks to be other sedimentary type rock as well, which I think is really cool, and that's again one of the reasons why we want to go here.
Addie, so it's hanging out in Yezero Crater here. The plan is to not only explore this area and look for ancient signs of life, but also to snag up samples of this dirt and dust and bring it back. Tell me about that aspect of this mission.
Yeah, so one of the things we've been wanting to do for a long time is Mars sample return, is actually bring a sample back from Mars. We think we have some samples that are from some meteorites that are from Mars, but we haven't actually ever brought a sample back because it's hard. Getting to Mars is hard, and then getting to the surface is hard, but then actually bringing something back requires an entirely different type of mission. And so this has been in the plans for a long time to do Mars sample return. And so one of the things Percy is going to do is what we call cache, or get some samples from a few of the different places it's going along its route, and then it'll leave just like a little treasure bucket on the surface with a little, beacon that says, "Here I am," for a future mission that's going to go and land on the surface and pick up that cache and bring it back. And they've actually started formulating the team that's putting together that sample return mission.
Yep. So it's scheduled for, I think, 2026. And so what I heard about, just kind of funny fact about it, is when you think about this new system and Percy, as you know, it's drilling into the Mars surface, collecting this sample, then there's a separate arm that grabs that sample, puts it in the belly of Percy, sort of kind of like, to ensure and storage, and then it's going to leave these samples on a specific area. And when I think about it, or what I heard, it's kind of like Percy is pooping. So it's like it's leaving the samples so that when we come back in 2026, we can pick those up and then actually take those samples and bring it back here, which is really neat because, like Addie was saying, it's the first time that we're going to be able to do that, and we have all of the technology here, so it's going to be really neat to be able to test those.
So pooping samples, that's for a future mission. But right now, Perseverance has a slew of science equipment to take close-up looks at the surface, like this view from Watson, which is part of the Sherlock ultraviolet spectrometer. Look how close we're getting into the surface there.
You can tell.
Isn't that cool?
Engineers and scientists like fun names.
Yes,
we do. We come up with acronyms
for everything.
And Watson and Sherlock.
So this is a spectrometer.
It is.
Addie, tell me a little bit about
Spectroscopy?
Spectroscopy, yes. And Kyle, we can actually switch to the next slide because this is a little disorienting. It keeps doing that. That was my bad, sorry.
Sing in the background.
So tell us a bit about spectroscopy.
Yeah, so...
Am I saying it right?
Spectroscopy.
Spectroscopy.
Mm-hmm.
Yeah.
So all the pictures we've looked at so far are visible camera images of the surface of Mars, which are amazing and are a lot of times the best ways to convey a lot of the information that we're getting to everyone, right? You can see this picture and we can all relate to these pictures. But scientists get really excited about like squiggly lines on graphs. And that's what we see when we see spectroscopy typically is, fancy squiggly lines on graphs. But spectroscopy is just a way of breaking down the light a little bit differently and looking at specific wavelengths and sort of how much of things there are at specific wavelengths. And basically, different rocks, different minerals, different gases in the atmosphere, right, emit or absorb at different wavelengths. And so you can tell what's there by looking at things spectroscopically. And so we have there's an X-ray spectrometer, there's a UV spectrometer. I need that first picture up again. But there's several different wavelengths of light that we're looking at to analyze these rocks and look at them in different types of light, basically, to understand what they're made out of and tell us about their history.
And Derek, that can tell us if there's these biosignatures in them,
That's
right? That you were talking about earlier?
Yeah, so what you're seeing here, what I'm seeing as somebody who's into geology, into the rocks, is sedimentary rocks are essentially built from sediments that are concreted together, essentially formed into rock. So again, if you're seeing this kind of rock here, it could have lots of different minerals and deposits that have been sent from this river and deposited here. So when you do the spectral work, when you blast these rocks, you can figure out what it's made of. And if you can, then you can deduce, well, there could be something in there that was formed from some type of biosignature.
Rocks and stuff, they're cool. But I think what's really exciting about this mission recently is the helicopter, right? So let's talk about the helicopter Ingenuity. I think we have some Ingenuity fans out there. Look at this little bug. I can call this guy a little bugger, right?
You can call this little bugger.
I was going to say, yeah.
So let's bring Joan in the conversation again. She is the engineer here. This was a proof of concept to see if engineers could fly a helicopter on another planet, and they did. This is the first time anything has ever flown off-world. What are the engineering challenges behind something like this, Joan?
Well, so we talked about the atmosphere and how, it's extremely thin. And so when you have a thin atmosphere different from Earth, you're trying to generate lift. And so, trying to fly something on a different planet is extremely challenging. And not only, you want to fly it on a different planet, but you also need to make it lightweight because of the atmosphere. And so this specific drone-like Ingenuity is about 4 pounds. So, not only are you trying to generate lift and try to do it at a very lightweight, but also you have to survive the Martian nights, which I believe it's like negative 130 degrees Fahrenheit. So, it's very cold, and you have very complex systems on here. So you need to make sure that it survives those nights, because if it doesn't, then that's it. There's no flight on Mars. So, it's really neat, the engineering that went behind it, because again, you had so many different elements that you had to think about. And then also for this one, I believe it's on its 6th flight sometime this week. And so we've already had 5 successful flights. But the neat thing about this is it had a callback to our first flight here on Earth with the Wright brothers. It had a little piece of history on it. The NASA JPL engineers were able to put a piece of material from the wing of the Wright brothers aircraft that had a first flight here onto Ingenuity. So even though it was 4 pounds and it was really, really tiny, they still had that vision to put that historic thing on the helicopter.
And a piece of that fabric went to the moon as well.
It did,
on
yes.
Apollo
Yep.
11,
On
and it's
Apollo
here in
11.
Orlando. You can see it at the Orlando Science Center, which is really cool. I don't know a lot of
I
people
did not
knew
know that. I
But
wanna
yeah,
go
it
there
is
now.
here if you want to see that. So, Eddie,
No, I was just
you're just gonna say how cool this was?
Yeah, that
It's
sounds
super
really
awesome.
cool.
Ingenuity
trip
is super
afterwards,
awesome.
right?
Yeah, there's a lot of what we do with some of these missions is focused on the science, but we try to do these tech demonstrations as part of that too, to advance what we can do in the next missions and in future missions. And there's hopefully going to be a helicopter or a quad octocopter that flies on Titan.
Titan, yeah.
In the
Yeah, the
future.
moon of Saturn.
Dragonfly. But Ingenuity is amazing, and it's been doing these tech demonstrations, and after it does this flight, I think it's actually going to go into an operations mode and do some scouting for Perseverance, which is like definitely what we can think of as the future for both robotic and human operations on Mars or other places, where you do a little scouting ahead of time and say like, okay, this is a good path to go, and this isn't a good path to go.
Right,
So
and
it's
if you
pretty
have
amazing.
different areas on Mars, you can send equipment, through drones and be able to do that. Yep, absolutely.
Let's just face it. We want to fly drones on Mars. Who doesn't want
Who
to
doesn't,
fly
right?
drones on Mars?
And not only did we fly drones on Mars, but we actually took video of it there. And I think this is probably the coolest thing about this mission. And we're going to play some of that video. And I think the most exciting thing about this mission for me was not the cameras, not what it was doing, but there are microphones on this. And as a radio guy, I was super excited that there were microphones on the Mars Perseverance rover. And these microphones actually caught sounds of not only the Martian wind, but of Ingenuity flying. So we're going to listen to that right now and watch a video. So just close your eyes and imagine, well, don't close your eyes because you want to see this too, but close your eyes for a moment and then open them back up and watch this video of Ingenuity flying. Kyle, go ahead and play that video for us if you can. And that's it down there in the little corner there, in the right-hand corner.
We need a laser
And that's
pointer.
the sound of Martian wind. you're actually hearing the rotor blades there. That's what we're picking up.
That's part of it too.
That's not it. That's not it.
It's disappeared for a moment.
You can still hear it though. They could hear, yeah. I know, right?
What are you hearing, Joan? Are you, as an engineer, do you hear anything funky? Anything to worry about?
I hear aliens somewhere in the background. No,
It's an alien aircraft.
No, I mean, like everyone right now, we're just trying to hear it. It's just so amazing to be able to have the technology to be able to hear something on another planet. So right now, I just
there
hear
it is.
my heart just going palpitating.
I know.
And look at that little thing. It just
It comes
It's
right
so
back.
tiny.
right back to where it needed to go.
It's a little bugger.
Little bugger.
Yeah, and the microphone that we're using is actually part of one of the science instruments. And
It's on Supercam, right?
It's on Supercam, which is a good name too. You can hear it slowing down.
Yeah. It's powering off.
Isn't that crazy? Like, I mean, that's
insane.
some 200. That's a football field away from the Rover at that point, and that's what it's seeing. That's so
Yeah.
cool. How cool was that?
That was awesome.
Yeah.
How cool was that? And I think our next slide is a great little shot of it just hanging out on the surface
There
of
it is.
Mars. Look at that. Look
So
at that.
Look at
Little 4 pounds.
So we talked a little bit about how something like this could possibly help future missions, right? I mean, this could be a scout for a big rover, right? I mean, that's the plan for these things.
Yeah, exactly. I mean, essentially, you're going to have all these little scout drones looking for places. It's also to help, not waste time, especially with Perseverance. Before with Curiosity, you kind of had to blindly go and explore. Now we have a better sense of, right, this looks good, go there. So it actually speeds up the scientific process.
Yeah, I mean, for current missions, we use orbital images, so images that come down from the orbiting spacecraft. And though we have those in really high resolution, they're still really good images. And we do a lot of scouting and higher specific imaging with this orbital spacecraft before we do a mission. But having just that ground truth and the higher resolution that we can do on the surface is pretty amazing.
There could be a smaller rock or some obstacle you can't just get with that orbital element, but having something that's just over a little bit, just to see those things, can help find those obstacles even more.
Absolutely.
Joan, this was a flagship mission. This was a milestone mission, a superlative mission, the first time we've ever flown anything on another planet. From an engineering standpoint, I mean, what kind of momentum does this give teams like the team that are working on Dragonfly that's going to go to the moon of Saturn Titan? How big of a deal is this for engineers?
This is huge. I mean, people usually ask me, why should we spend money on space exploration? Why should we give money to, explore other planets when we have our planet here? And so this is a really good example of, we need to explore other planets to understand where we came and where we're going. And so therefore, as an engineer or scientist or anybody involved with these missions, there's just a sense of pride to be able to not only, fly for the first time on another planet, but, scout for future missions, be able to learn from our past and be able to get ready for the future. And so therefore, one big one is one of the space companies, billionaires are trying to get us to Mars. And so therefore, these missions are helping us figure out where specifically we should be able to build the colonization if we ever get to the planet. And so therefore, it's just really neat to be able to see all of this technology in front of us.
And it's just like super cool and exciting, right? It just adds that, crazy awesome element that is inspiring and is exciting and is things we can talk about and listen to.
Yeah.
And it was a last-minute addition to this mission, right?
It
wasn't planned from the onset, so that's
Yeah.
really cool. So flagship missions like this really capture the curiosity and public support for space exploration. I spoke with Marketplace Tech host Molly Wood. Do we have any Marketplace Tech listeners out in the audience there? Listen in the morning? All right, good. Well, I had a chance to talk to Molly Wood about the public perception of space exploration and the growing space economy. And here's what she had to say. So, Molly, you are a self-described space nerd. It says so in your Twitter bio, so I don't feel bad saying that. I've got to imagine that means that you're watching the Mars landing earlier this year, were you not?
Oh, absolutely, yes. Me and all the other space nerds. And it is okay to say so. It is 100% true.
So, I mean, what drew you to this mission? Why do you think, the hundreds of thousands of people, followed along at home as this little bugger was landing?
I mean, first of all, I have to say that it's credit to NASA and its media operation that all of these things are so lovable and they have names and personalities. So it's sort of irresistible if you have any interest in space because they've been so well personalized. But there's no question that this, like the moon did several decades ago, just ignites the imagination. I mean, what we really are doing, what the stated goal of so much of this exploration is to figure out how to make humans into a multiplanetary species. I mean, they're not saying that exactly. It's sort of like conditions for life, extract a little oxygen. But how could you not be captivated by just the baby steps? If we are in the infancy of that process right now, you got to watch every minute.
You cover a lot of those steps on your show, and you do look at the space economy. And I'm thinking back to an episode you did back in 2018. So here's a pop quiz, see if you can remember that far back. But you interviewed a guy from a company called Made in Space, which happens to be in our backyard here in Florida. And they're about building things in space. So if you remember, they've got some stuff on the International Space Station. But it was a broader conversation about why we'll need to build products elsewhere instead of bringing them with us. And it got me thinking, just how important is the private space industry going to be as we take the next big step and go to a place like Mars?
Absolutely. I mean, I think, Mars is very sexy. And in the short term, this kind of nascent economy, the huge economic boost that's just around the corner, is this what they're calling low Earth orbit potential band, right? And there's all of this opportunity for economic development there and for, yes, manufacturing in space and creating essentially way stations. Of course, the reason it's important, as you well know, the reason it's important to find oxygen and water on Mars is not just so that we can live there, it's so that we can make rocket fuel in situ to get people off of Mars so that it's not a one-way trip. It's the same thing with this manufacturing in space, the ability to create way stations along the way for either refueling or as bases to launch even further into space. And then on top of that, I do remember that interview because that's what a legitimate space nerd I am. Like, that guy, that was great. Is that, manufacturing is dirty and occasionally inefficient and requires a lot of land. And the closer we get to realizing the scale of the climate crisis, the more sense it could potentially make to start off-planeting, not offshoring, but off-planeting manufacturing into space. Obviously, we're a long way from that. But as we start to sort of figure out what we can and can't accomplish in low Earth orbit, the possibilities start to get really significant.
And finally, Molly, another growing segment of the space economy is space tourism. We've got, Blue Origin and Virgin Galactic, and even SpaceX, who is sending a civilian crew as early as later this year from Kennedy Space Center. I'll leave you with this final question. If given the opportunity, will you host Marketplace Tech from space?
I was just going to ask you if you would do it.
No way. I report on the explosions too much.
I know. I mean, that's the thing. It's sort of like, if given the opportunity, I would not want to, but I would have to.
Well, Molly Wood hosts Marketplace Tech, for now firmly planted on the ground here on Earth. You can hear it most weekday mornings at 7:45 on WMFE and WMFE, or subscribe to the show wherever you get your podcasts. Molly, thank you so much for joining us.
Thanks, Brendan. What a blast.
What a blast. She uses the puns like I do. I love Molly. So Molly spoke about those human missions to Mars and how the private sector is going to help us get there. But there's also an experiment on Perseverance that will help prepare Martian astronauts. And we actually have one of our first questions from our listeners out there. Hashtag Ask WMFE. Josh wants to know if we can discuss MOXIE. What is it, and what will we need to do to bring it to scale, to bring people onto Mars? So first of all, let's talk about MOXIE. What is MOXIE, and why is this so exciting?
Moxie in this case referring to an instrument on Mars, not like, do you have Moxie? But Perseverance does have Moxie. It's an acronym that I don't remember. But
You, Joan? No.
No, we just go with the acronym.
Nobody studied for this? My goodness.
The O is oxygen. The O and X are probably oxygen. But basically, Moxie is an instrument that's taking carbon dioxide from the Mars atmosphere and turning it into oxygen, which is remarkable because we need oxygen for water, for breathing, for rocket fuel, all of these different things. And if we can pull it out of the Mars atmosphere, we can use it in situ, there on the surface. And so Moxie is a really cool tech demonstration that's showing us that it's possible, and it actually operated for the first time a couple weeks ago and did its little demonstration, and they're going to keep testing it after that.
So it's like a tree.
Yeah.
In many
little
ways,
metallic
too,
tree.
one of the things that Joan mentioned before was that a lot of the technology that's being developed by NASA and other space agencies is supposed to be used here on Earth. So using this kind of technology could help us sequester carbon dioxide and other things to help with our climate issue as well.
Joan, this is just one of many things we'll have to figure out before we send humans to Mars. What are some big questions we still need to answer before we can send not just astronauts, but people to the surface of Mars?
I know, I think it was a few years ago, there was a competition. It was like Mars One, right? Something like that, where like they had a group of people who were like, yes, I will leave my family for that one-way trip to Mars, and that's it. I will go. And so, yeah, there's just a lot of things that we need to think about. The trip to Mars, how are we going to survive that trip? I know that astronaut Kelly was in the ISS for about a year, so we were able to understand the toll that it takes being in space for so long, because I think it was a 7-month journey to Mars, and therefore if something ever goes wrong, there's going to be that 12-minute delay between Houston and also the crew on Mars. We need to figure out the oxygen situation. We need water and oxygen recyclability, and we, again, as a human element, we need to understand how is our blood pressure going to survive out there, how is our bone density going to survive the journey to Mars and then still be on Mars for a very long time, and then the food element as well. I know that we have a lot of experiments right now in the International Space Station, and we also have a food lab here at Kennedy Space Center who is trying to understand how we can build food, on different planets. I know that The Martian was a really popular movie, and Matt Damon had his poop potatoes. So something like that we have to figure out first in order before we send humans to Mars. And we definitely, I know that she was talking about the element of return, that we just don't want to send people as a one-way ticket. We want to make sure that we can safely bring them back as well.
Yeah, and a lot of that is you don't want to have to take everything with you. So what can you make there? What can we use on the surface, whether it's building habitats from the dirt and the regolith, or whether it's making oxygen to breathe and then to fuel our rockets to return. We have to have all of those things, and not just on Mars, also on places like asteroids and other way stations along the way.
This has been a great conversation. Let's go ahead and take some questions from the audience. You can go ahead and tweet us with the AskWMFE hashtag. And I want to jump off of what you said there, because we got a question from Andrew that did bring up kind of the science fiction version of Martian exploration, like Andy Weir's The Martian and Matt Damon's potatoes, his poo potatoes. I mean, how close is science fiction to science reality at this point? Have they got it right?
It depends on the science fiction. The Martian is for most of it, it's a very realistic exploration of what the environment is like and what challenges you would encounter there on the surface. There's a little bit of it starts off with a bad science, but then is really good with the science and engineering most of the rest of the way.
It is pretty good.
Yeah.
What's your favorite science fiction? I think I know the answer to this.
My current favorite science fiction show is The Expanse.
The Expanse. That is my favorite show right now, too.
Yeah, because it's also for the most part, very realistic in how it treats operations in microgravity, how it treats using asteroids, and also it's a very interesting social exploration. So
Yeah, as someone who worked for Blue Origin before working currently at NASA, obviously it's owned by Amazon, and so therefore a lot of the scenes that they used, if you haven't seen one of the landings that they did on one of the planets, they modeled it off of the New Shepard landing, and so it was just really neat to be able to work on something that has been on a show. So it is very realistic, and I love that show.
That was a dangerous question because I'm on book 1, like halfway through, so no spoilers, please. No spoilers. Oh, we got another
You've
question.
seen the movie though.
Everyone
I know.
dies.
Well, The Expanse.
Oh, The Expanse. Oh, yeah.
Yes. So,
Yeah.
so we got one question here from Kitty, and she asks, "How do you make sure you don't bring organisms back from Mars?" I know there's a lot to make sure that we don't get organisms from Earth to Mars, but how are we going to make sure we don't bring Martian organisms back when the sample return?
We're going to scare them with sirens, I think. Just say, like, don't come back. A big thing we do is called planetary protection. So a big part of NASA is planetary protection. Before Percy launched, we had to clean it it's kept in a clean room. You saw the picture of Ingenuity, all the folks in the bunny suits in the background to keep them clean before they go there so we don't cross-contaminate. But then as we're doing sample return, how do we not bring organisms back and have some of those scary sci-fi movies that are probably less realistic happen? Well, in one way, when we bring back the Mars samples, we kind of hope they have some organisms or signs of life in them. They're not going to have live organisms. But those we'll keep in very close containers and really sealed environments. For the most part, most places we go, like the moon and asteroids, we're not too worried about bringing any live organisms back. We haven't seen any protomolecule yet. So
Yet. Okay.
Yes.
But we do have pretty specific measures in terms of like how we treat other planets. So when Cassini ended its mission, for instance, it crashed into Saturn in order to protect places like Europa and Titan that might be places where life could exist elsewhere, and we don't want to contaminate those places.
Mm-hmm. Joan, this is a question for you. If Mars has little atmosphere, is it easier to land things there than Earth?
No.
And
The
why
simple
that?
answer is no. No, it's still extremely difficult to land. Like we mentioned, I mean, the communication delays, just in general, everything has to be autonomous. You have to test everything here on Earth because you're not going to be able to. If something goes wrong, you can't self-correct. You can't tell Percy or any other rover where to go and how to do it. Everything has to be autonomous because of that communication delay, and so that's why the technology has to be, up to par for us for Percy to land on its own, essentially.
Yeah, and it's why there were like 5 aspects of the landing, right? There was the initial parachute to slow it down a little bit, but the parachutes don't work very well in Mars' atmosphere because it's so thin, and we used to land with big bubbles around our vehicles, but then they got too big for bubbles.
I would say that it's hard to land, but it's a lot easier to launch off of Mars because less gravity means so. So there's always a give and take, right? So. Again, like when people see, the lunar exploration module lift off from the moon, it's like nothing, right? Because it takes a lot less work it's the hardest part is getting off of Earth and landing on another, but at least you can launch and it's not as difficult.
We have a lot of questions coming in, so I'm going to try to rapid fire them to
right.
you all. Okay, Derek, I'm going to give you this one, Derek. This one's from Matt. And he asked, the photos of the Martian landscape that we saw earlier in the program, was that an accurate representation of the visible light color spectrum, or was that edited for viewing? What would it actually look like on Mars?
So I believe the picture that we did see was a visible image. So it has that very oxidized look to it because, again, the oxygen that was once rich in the atmosphere of Mars was either stripped away due to solar radiation or was highly oxidized in the especially iron-rich rock found on Mars. What you're seeing in those images is real colored images. So if you were on Mars, that's what it would look like.
Another one, and this is kind of a similar question we get a lot, is, how can exploring Mars help us here on Earth? What kind of technology are we developing or understanding are we uncovering by doing missions to other planets like this?
Well, again, the thing with the MOXIE, again, we're using that technology to hopefully eventually help with, sequestering carbon dioxide. But the other thing, too, is energy resources. When we go to Mars, we have to figure out ways to utilize limited resources to produce energy, all the things we need to survive on the planet. those are going to help, in places that are more remote here in the world to create energy resources, communications, all these things. So again, the mission, a lot of the stuff, if you go back to the Apollo missions and eventually with the new missions like the Artemis mission, you're going to see technologies that are going to be developed that are going to help us here on Earth. And so going to space, people always say, why do we want to spend all this money going to space? It's going to impact you. Every phone that phone that you have in your pocket or your hand, those microprocessors were developed by the use of going to the moon and so on. So in the cordless power tools that we use, smoke detectors, the list goes on. The things that you use on everyday life stemmed from these test developments and going to places like the moon and to Mars.
And we also have satellites that orbit our planet as well. And so NASA not only wants to explore other planets, but we want to explore our own. And one very good example is last November we launched the Sentinel 6 right now that's orbiting our planet. And right now it is collecting data on the height of our oceans, which could help us combat climate change. So not only are we using the technology for other planets here on Earth, but we're using that technology to explore our own as well.
And there's a cool web page on NASA's website that's the technology development and technology transfer and how it's been used in different places. And it's a pretty fun graphics showing you like how something that was a microprocessor was developed and how that works its way into everyday life.
On our phones or in our car.
A lot of questions we're getting are about the time, what it will be like for those first astronauts on Mars. Can we kind of just imagine what it would be like if the four of us, well, the three of us, I'm not going, if the three of you went to Mars, what would you have to experience and what would you endure on the surface of Mars as an astronaut?
So the biggest thing I worry about when I think about going to Mars is radiation. So that's one of the biggest things we're going to have to protect against. Going to Mars, sort of just as an exercise, is going to be a lot like going to an extreme environment on Earth, like Antarctica or some of the high deserts where you need a spacesuit for protection. You need a habitat that's going to be able to protect you from the elements and keep your potatoes and your other food, right? And so I think that there's a lot of good remote studies that are done that help us sort of pave the way to understand what it's like to be on Mars. But I think, honestly, we don't know. I don't know. I think it's one of those things where until we go there and are living on another, even if we're not living, we're just briefly stopping on another planet, it's just going to be an entirely new experience.
One of the things that people don't realize is we can't just build a habitat on the surface of Mars. So we're looking for lava tubes in terrestrial areas or shielded areas because of the solar radiation from Mars. It lacks a magnetic field. That magnetic field that's generated by the core of our planet is protecting us from this excess radiation. So when we build these structures on Mars, we have to make sure that we are protected because that's probably the most dangerous aspect. But the other thing too is, as was mentioned before, if we have people that are on there long term, they come back to Earth. What is that going to mean? Or the heart rate, the blood flow, blood circulation, muscle mass, bone density. Will they develop things that that we had no idea of? Was it Scott Kelly that had a lot of issues with his legs when he came back because of his heart shrunk? There's so many different things that we can't completely do, even though we have analog astronauts here on Earth that are in these places like up in Hawaii and the Arctic and all these other locations that are essentially trying their best to simulate what it's like to live on Mars. There are still things that are going to surprise us when we get there.
Yeah, absolutely. Dr. Cyan Proctor is a really big analog astronaut. She's one of the ones that was chosen for Inspiration 4 and really big science communicator in the community. And, she does all of these missions. They go out there for 6 to 9 months, but, they can't really understand the human physiology aspect unless you're actually on the planet. So it's going to be a little bit challenging when we actually get there.
Mm-hmm. And just to close out the night, we've been talking about Mars all night, but there are so many other cool things in space. So in the last few minutes we have left, I want to go through and ask the three of you, what else should we be excited about in space exploration? I'll start with Joan.
So there is one mission that I'm extremely excited about because I'm a
Me
part
too.
of.
I love this one.
So there's a mission launching at the end of the year called DART, the Double Asteroid Redirection Test, and it's launching from Vandenberg in California. And so what we're trying to do with DART is it's a planetary defense mission. So if any of you guys have seen the early 2000s classic from Michael Bay, Armageddon, we have Bruce Willis and Ben Affleck being able to. There's an asteroid heading our way, and the only way that we can survive is send Bruce Willis and Ben Affleck to go there, drill a hole, drop a bomb, and explode it, and we'll be fine. That is plan B. However, for plan A, we need actual defense for our planet. And so like we were mentioning before, what does NASA do for just ourselves? Well, this mission specifically is going to be sending a spacecraft to a double asteroid that's about a year away. So we're launching by the end of this year, and we're going to Didymos, and we're going to try to essentially get the spacecraft to collide with this moon. So there's two asteroids. There's a Didymos A, Didymos B. We're trying to collide with Didymos B because it's a smaller version of that asteroid, and we're trying to essentially redirect it to a different path. So if there's an asteroid that's ever headed to Earth, we're hit with asteroids all the time. That something as big as a table, but we don't know because it burns through our atmosphere. And so this specific asteroid that we're heading towards is as big as the Washington Monument. So if it ever hits planet Earth, it could be catastrophic, like the dinosaurs. And so, what we're trying to do, again, is we're trying to redirect, and it's just a really neat mission to be a part of and being able to work with all of the different elements, and I'm really excited about it. You don't really hear it on the news as much, but I'm really excited. I'll be in California in Mission Control out there and being able to, see this spacecraft launch to save our planet one day.
I have done a few stories on it, and I have to thank you for going to Didymos, because that's the most fun word to say on the
really
radio.
is.
Didymos, yeah.
And for a while, the other thing was Diddy Moon.
Diddy Moon.
But they renamed it, but I still call it that.
Very cool. DART will be really interesting. And remind us again when that launches. That's very soon,
End of
right?
this year.
End of this year on a SpaceX Falcon 9,
When does
right?
it get there?
It gets there next year. So it launches this year, and then the asteroid's about a year away, so it's going to collide with the asteroid sometime next year.
Very cool.
The asteroid is not going to hit us.
The asteroid, no. So
Thank you.
I know last year there was some misinformation of there was an asteroid that's heading to Earth and it was going to hit us. There's always, but this one was special because it was supposed to hit us on Election Day.
Oh,
and so, I had to put out a video no, it's not going to hit us, but if it ever does, this mission will help us, and so I'm really excited about it.
Derek, do you have anything cooler than Didymos to tell us about?
Well, I'm really, really excited. As an astronomer, I've been waiting for this for years. The James Webb Telescope will finally be going up, hopefully in October of this year.
On Halloween.
Halloween.
The spookiest
I know, Halloween.
of launch
My
days.
favorite holiday of the year, too. It can't get any better than that.
I
So,
hope you have your James Webb costume
What's your alter
ready.
ego in Halloween?
Dr. Demetrius Deuteron. Yeah, Dr. Demetrius Deuteron is my alter ego. And we'll be celebrating that way. But anyways, I'm excited about this mission. It's going to be... this thing is massive, and is going
Right
to
about
be,
the size of the stage, right? When the
it's
sun shield is
huge.
open.
Yeah, it's about that big gold-plated. It's incredible machinery, and one of the things I'm most excited about is we're really going to get a better glimpse of Earth-like worlds out there, exoplanetary systems. That, of course, one of our missions too in life and humanity is looking for where can we go that could very likely be a place that we could one day visit, or maybe there is life looking back at us. This is one of the things I'm most excited about with James Webb is we're actually going to be able to look and really measure what the atmospheres of these planets are like and get a much better resolution to it. Now the question is it's not like the Hubble Space Telescope. It's not visual. It's going to be looking in the infrared. So it's a little bit different than what you would see with the Hubble Space Telescope. But this is going to be the next generation astronomers that are going to be, this is something that's going to be, several decades of astronomers working together to solve a lot of these amazing mysteries of the universe. So I'm excited about that.
So we have a mission that's going to prevent the possible asteroid death of this planet. Another one that's looking into our ancient past through infrared. Addie, can you top that? What else should we be excited about?
I don't know if I can top it. I was going to say, you just did a story about James Webb on your show.
Yeah, we looked at
I am most excited about lunar missions.
Okay, that's
about
cool.
missions
That's
to the
cool
moon.
stuff, yeah.
It's not looking into our deep history, although there's a super cool telescope that's been proposed to be on the moon or to orbit the moon to study
That's right.
the age of the universe.
Yes,
Super
yeah.
cool mission. I'm excited about lunar exploration because it really involves a lot of what we've been talking about of this both science and technology and both robotic and human exploration coming up, and it hopefully will be able to send scientists to the lunar surface soon, but we're at least sending instruments in the near term. And so I'm really excited about going back to the moon and going forward to the moon and all of the exploration that's going to be coming up in the next few years.
And a lot of that happening right in our backyard here at the Kennedy Space Center. A lot of those launches.
And the moon's
there.
up right now. Look at the moon
There we
right
go,
now.
yeah.
Look at it. Enjoy it.
Well, that
It's
is
right
going-
there, but we can't
That's
see
right.
it.
Oh, we
We'll
can't
get
see it.
it.
I think it's
Yeah, I know. We got this
Trust
thing.
you.
Well, that's gonna do it for our show tonight. Don't forget, you can stay up to date on all the happenings in space by listening to our space exploration show, Are We There Yet? It airs every Tuesday night at 6:30 on WMFE, America's Space Station. You can subscribe to the podcast on iTunes, NPR One, or wherever you get your podcasts. And a portion of this conversation is going to air next month on the show, so you'll hear some of your claps and your woos all on the radio. So I want to give some thanks to everyone who helped put this show together. Special thanks to Erica Pulley-Hayes, Christine Hetzel, Ryan Ellison, Amy Griffith, and her team, who I know is out here. Editorial assistance this week from Danielle Pryor and Matthew Pitty, who is not here tonight, I don't think, unfortunately, so you didn't hear my terrible accent. A very special thanks to our event sponsor, Orlando Science Center, and our Community Advisory Board Chair, Meredith Sand, for kick-starting this event. Meredith, thank you so much for the idea. And thanks to our panel, Dr. Addie Dove. She's at the University of Central Florida, planetary scientist, and a frequent guest on Are We There Yet? Derek Demeter. He is the Seminole State College Planetarium Director. More info on programs and the facility at seminolestate.edu/planet. And Joan Melendez Misner. She is an integration engineer and science communicator. Follow her outreach efforts on yourfemaleengineer.com, or my new favorite place to find her on TikTok. She's at Your Female Engineer. And most importantly, thank you to you, our listeners. Our listeners and supporters fuel this rocket that we call WMFE with your generosity. So help top off our tanks and continue exploring the community, planet, and universe we all live in by visiting WMFE.org/support. Thank you all very much for coming out tonight. It was so great to see people in person again. We look forward to doing more of these again. Until next time, I'm Brendan Byrne. Thanks for joining us.